Can you make me host? I mean, like a presenter at least. Okay. So, screen disable. Okay. So, quick agenda because we seem to be going over things not slightly slowly. So, maybe 10-15 minutes review homework. Then look at plots today. For most part, different kinds of plots. I know we already started last class and you guys did something in the homework as well. But for most part of today, we will just look at different plots. And we'll talk about some interesting questions that you can ask about the data set. And finally, some homework discussion, like what kind of problems you want. For those of you who have attempted the homework, do you guys have any questions? If not, I can just quickly go over. I can only go over the questions. Otherwise, I would have to spend time doing other things. Does anyone have any specific questions? Let me see if I can. So hopefully this one. How do you plot two different DFs on same graph? Is that a general question or like, I don't remember? That's a general question, right? How do you plot two different data frames on the same graph? Yeah. So what do you mean by like plot two different data frames? So some example, like for example, we have one data frame which we have been beating to death, which is the one for athletics or Olympics events. What's an example? You can speak women medalist and male medalist. That is same. So you want to like filter the data and, but so you're talking something like this. You mean like number of medalists per year or something like that? Number of medalists per sport. Okay, so let's see. So we can group by sport and let me see what are the columns. We'll group by sport. Thanks. And we'll filter by. Could you go over how to filter a data set based on multiple conditions? Okay, so let's first filter this data set. So we only want the medalists in this one, right? So Darren's question, not related to homework, we'll just go over that. Actually, you know what? Let me just write down your questions. I'll write down these questions and then we'll go over them after we finish the homework review. So any other questions? The first question that Darren asked. So this is Darren's question. Any other questions? Shruti asked another question, which is how to filter a data set based on multiple conditions from Shruti. Any other questions? Any other questions, anyone? Last question. Okay, homework. Yeah, we'll go over homework. So first one, how many sports and events were played? Do you know how to do that? Like, so in these years, 1992 winter, 1994 winter, how many sports and events were played in these years? Okay, first of all, how do you get the data first? So if you want to get the data, 6,149. Oh, you added up the total. Okay. Okay. I guess I can accept that one. Okay, so let's just take this question. So how do you do this? How do you go about it? For those of you who haven't done it or who are still doing it, how do you start? So we want to first get data for year equal to 1992 winter, year equal to 1994 winter, and 2000 summer, 2002 winter, and 2004 summer. Okay, yeah, I think I remember the number 7536149. Yeah, I think that was what I remember, but I don't recollect. So okay, so first things first. So you want to filter athletes events, right? So now in this, you can say athlete events of year dot is in, right? So this is one way where you can filter relatively easily with this is in thing. So let's just see what this gives us. So this gave us everything with those years, right? And in this case, we just ended up being lucky that in 1992, there would have been only, oh, it looks like there is Summer Olympics and Winter Olympics in 1992. So we have to now also say little bit more. So this didn't work. Like if I just try by year, I'm getting both 1992 Summer Olympics and 1992 Winter Olympics. I just want 1992 Winter Olympics without getting the 1992 Summer Olympics. So we have to say something like athlete events of year equal to 1992 and athlete events of what is this called? Games. Oh, actually we have games. So we can use games, which is also already an aggregate column. So athlete events of games dot is in, and you can give it a list basically. So 1992 winter, 1994 winter, 2000 summer, 2002 winter, and 2004 summer. So this should give us all the data that we want. How do you verify that this gave us all the data that we want? Oh, okay, yeah. So if you didn't see games, yeah, that's what. So that hopefully answers the question. So there is a column called games. You could actually do it based on that. If let's say there is a column called games wasn't there, how would you do this without using the column called games? How would you do this? You'd have to do something like this, right? You would have to say year equal to 1992, and I think it's called season equal to winter. Right, so this is one condition. Yes, we are going over number one. But assuming if there was this column called game, if the column called games was not there, how would you do that? You do it something like this. So you'd have to go 1994 winter, 2000 summer, 2002 winter, 2004 summer. Would have been very slow, but still would get you the answer that you want. I mean, it won't be slow, it will just be hard to type, but so how to check that these two things gave the same answer? We'll just compare based on the numbers, total numbers, won't try anything more. So we got 37,000 rows one way. Start clearing the results. And in this also 37,969 rows. So right, you used games. Exactly. Yeah. You used games. There is nothing wrong with using games. But if this column called games was not there, then you would have to do like this, right? You use and this game, this or this or this or this. Because a column called games exists, you don't have to worry about anything. But now you don't have to do even this. You can just go athlete events dot group by of by equal to games, and then start counting dot in unique or dot count. I should still filter. So should still filter by this. So I just want the count of two things, right? So I want games, event, which comes out by ID, and sport. I just need 3 columns. Oh, probably made some mistake. What did I type wrong? Yes, I'll share the collab. Just a second. Okay, I shared the collab. This should give me some groups. Whatever you got answer, don't worry about it. You just have to worry about whether the approach is correct. Answer, I also don't know what's the answer, to be honest with you. So that's why I'm not really sharing the answer this time. So we got these groups, right? Now, what we are kind of asking is, would this be correct? Number of events. Yeah, sure. That could be correct. Yeah. If you drop duplicates. Oh, you are looking at the shape of things to get this. Okay. Yeah, you could. Yeah, that could be correct. Yeah, sure. Why not? But let's see. Oh, there is a column called event and there is a column called sport. Let's see what happens if I group by those. And then do dot value counts. Group by groups equal to identities. Yeah, sure. You don't have to use that column groups. You can just use whatever you get. So I think I can just say groups dot size. That would give me, yeah. So this is telling me how many. This is giving me something of length 797. So that's what I'm assuming is the number of events. And the rest of it is the sum of all of this, which we can check later. So this is a general approach. So you filter by this ease in, and if you want, you can group by just one column. Let's say you can group by event, and then you can count how many things you got. So there are 390 events according to this. If I just group by events, I'm just getting 390 events. Now you can also group by games comma events, which will probably give you all the events that are there across that. So that's giving me 797. So this group by is equivalent to drop duplicate. Some of you who are more trying this drop duplicate, this group by will also suppress the duplicates. It will give you unique values. You can even try with n unique. You can group by and try .n unique. And it's giving us a 797 unique values. If you don't want to do this, then you can just group by events, and that will give you the n unique, which is 390 events. And if you want the sport, you can group by, you're getting 205. You probably filtered by something slightly different. So that's probably what's happening. You have to see what you're grouping by or what you're suppressing. So you can try like this. The question itself, how many sports and events were played? So since we didn't exactly mention like total across the years, so this question actually, yeah, even though I saw this already, you can interpret it in two ways. One is across all those 5 games, how many total sports were played, or you can assume each game how many were played and then add it up. I think some of you might have done it one way versus the other. We will try to give points for both of the ways, whether you did it one way or the other. Satvik, it looks like the homework link is working, right? Like I'm clicking on it now. So I don't know what happened. You can take some time to look at that. Then the next one, between 1990 and 2016, how many events were played? Oh, the collab link. Oh, that's not working. Oh, this one here. Oh, this one here is not working. I don't know if this one here is not working. I didn't try myself. Oh, yeah. Looks like that one is not working. Yeah, that collab link has almost nothing in this particular homework. So if it doesn't work, no big deal. Don't worry about it. So I think the thing that we were really looking for probably was something along these lines. So now group by here and say like games of interest. How should I find some? It doesn't work with n unique. Yeah, let's see. So games of interest. So these are the games of interest. Now of these, I'll just get games, events, and sport. And then this is just a subset. And then this data subset, if I group by games and then get the unique across those, then I should get how many unique events are there. And so these are all the unique events, number of unique sports. So some of you seem to have added up, some of you didn't add up. No big deal, but this is roughly the unique numbers. How should I find the sum? It doesn't work with n unique. You mean like this total, Shruti, like this 57 plus 61 plus 300, that one? Right. Let's see, can we dot sum of event dot sum. So you could do this. So you could, because the n unique also returns a data frame, you can select the particular column of interest and do dot sum. Yeah, you can submit. I'll just not give all the answers then if you have all of you haven't submitted. Sure. Let's just go over the approach. This is similar problem, right? Between 1900 and 2016, how many events were played? Similar approach, basically. Almost no difference as such. Again, if you want to group by year and present the data by year, that's fine. If you are presenting a total, that's also fine. So for these two problems, the idea was group by, right? Because I think I had mentioned in the class before that you should group by something. So here we are grouping by games, here we are grouping by year, that's all. Next, plot a bar chart to show number of male versus female medalists. So this is all time, I think, right? Like it was not any specific time period. So first of all, how do you get number of medalists? How do you get number of medalists? Anybody? Other than Darren and Shruti and Satvik, those three have already answered enough for today. So other than Darren, Shruti and Satvik, how do you get the list of medalists? Okay, I'll go in alphabetical order. One of the three A's, Aditya, Anmol, Ayush. How can we get the list of medalists? Aditya, Anmol, or Ayush? Do you guys know how to do this? Can we see the subsets? Okay, so you'd say of medal. What would that return? This would just return the column medal. Can we see subsets? Yeah, how do you see the subsets? So there is a way to see like E is not null, right? Is not NA. No, is NA. So this will tell us whether it is if it is null or not value, and then you do this. So this can give you the, these are the 39,783 medalists. Does this make sense? Right, so you're filtering. Yeah. Okay, you can try not null also, right? Yeah. How did you get the true or false values? So what I did is first I went through this column, right? This column told me that there are not a number, not a number, not a number, and gold. So I said, hey, which of the rows have not a number? Is not a number. Now it returns true, true, true. So these are all the not numbers. So if I say equal to false, then it will be opposite order, right? So these are all, this is the only one which is a medalist. These three are non-medalists. We can do not null. There is nothing wrong with doing not null. So you tried pd dot not null of athlete events of medal, right? So this returns the same thing, right? So this is another method. No real difference. This is shorter. So you can do this one. So these two are exactly the same. There is no difference as such. These are two methods of finding out which of them are not nulls or nulls. If I don't want to see the nan value, how do I get the medal values? Right, yeah. So how many medalists do you have? If you want to find that out, you just add up basically. So if you, let's see. So first let's filter this. So we'll do it with this method, which is a more popular one at least. So we got 39,000 rows, right? So from this one, we want to get how many of these are for male athletes and how many of these are for female athletes. So how do I get that? I have to group by. I'll group by the gender and then I can do count. but it is showing me all the columns. I'm only interested in the medals column. So I'll only select 2 columns from this. So first, let's get this medalists. From this, as some of you know, we can also select only 2 columns, medal, comma, gender, and that's so, and then I would do group by. So this is the number of female medalists and number of male medalists. Now I just have to plot. So what I'm doing is first finding out who are the medalists. Is this part clear? The reason I'm asking this is because if we keep going forward to other topics without actually knowing filtering, it might be a little bit challenging. Oh, the data set link. You should be able to Google this way, Kaggle. As soon as I type Kaggle, because I have gone enough times to that. This is the link to the data set. I think, let's see. This is the data set. Yeah, this looks like the data set. Just check the first CSV file, athlete events.csv. So first I filtered the data set and found medalists, right? Then I'm only extracting 2 columns out of that, medal and gender. Then I'm grouping by the gender of the athlete and counting how many of them are there. Then I have to plot this, right? So I'll just say this is a distribution by gender, and I'll plot this one. What kind of plot should I use? We'll cover that later, what kind of plot to use. So I'll put this gender in this line, and yeah, bar chart is good. Yeah, cool. So let's see. Oh, so I have to. So, okay, so let me just go over what happened here, right? If I see this distribution by gender now, it has 2 columns. This first column is the index column, right? This second column is the values. So when I'm plotting, I want to use this column as the x-axis, this column as the y-axis. So I'm first resetting the index. So it'll add a brand new index, which has 0, which has more like a row ID. So I can reuse my columns here. Oops. In place equal to true. So I get something like this. So that's for that one. The last question, we'll continue on this question later, because this is actually an interesting one. The way we started initially, it was a very interesting one. What is a legend? Oh, actually, if you use colors, it would be different, right? Like here, it is easy to see that this is male, this is female. But if I wanted to use 2 different colors for each one, that would have been a legend. Right? So in this case, there is really no point of a legend, actually, to be honest, because both these are just 2 values for the same data. So I'm just plotting it. If I was plotting 2 different things, then legend would have made sense. I'm plotting the same thing, so legend here doesn't make sense. What does this thing do? So let's see what without that what happens. How many columns can you see here now, Meda? How many columns are you seeing? 1 column, right? This is the only column, medal. But I want to plot gender versus medal, right? So if I do reset index, what it does is it will make sure that this also becomes a column in the data set. So now I see two columns here, right? Does this make sense? So by doing this reset index, I made this thing a column in the data set. Previously, this was the group by index. And I'm plotting it. Can you guys hear me? Okay, yeah, not sure what happened. Suddenly got disconnected. Okay, so disable annotation. Okay. So in this case, legend actually doesn't make a sense. If these were two different things, legend would have made sense. I think we asked you to add legend, right? And access labels. So access labels are already there. Yeah, I think only access labels is sufficient in this case, really. Port. I think I should be able to do this. So if you want, you can set this as access label kind of. So Y label is number of medals. This is called Matplotlib. So you can set labels like this. Gender, number of labels, medals versus label. I don't think this would let me set a legend, but let me see. Yeah, because there is really only one date, one variable that we are plotting. So it is useless to set a legend in this case. You can maybe just call the legend also just gender. Okay, so this is that one. Last question, we'll go over it later. Okay, so we already saw some plots. In today's class, we will go over 7 different plots. And For number 2, it is asking, can you change the colors of the two bars? Yeah, you can change the colors. You can just give color as an index here. So one of the arguments that this thing accepts is color. And depending on how many colors, how many bars are going to be in your data, you could give as many colors. You can give more colors if you want. For number 2, it is asking for unique event types played between how many events were played. Is it asking unique event types? How many events were played? Just how many events? Each year, how many events were played? That's all. So for question number 2, it is each year, how many events were played? For question number 1, each season, each of these games, how many sports were played and how many events were played? So this is group by one thing, this is group by other thing as a hint, if you guys want to continue. Then the last question is actually little tricky, but you should first get the list of, so this is asking about people who are less than 175 centimeters height, right? So this is very tricky to actually do. No, it's actually wasn't too hard, but it all depends on how much you, how many different ways. There are actually 3 ways you can answer this question. Maybe a slightly different phrasing of the question. Let me phrase this question differently and see if you think it's the same. So this is the first way, right? Like the question that's there in the class, in the homework. Oh no, I mean, not in terms of number of lines of code. It actually is very short. All of them are very short in terms of how many ways you can think of this. So which sports do short people feature in a lot of events, right? So this is obviously very easy. But if I change the question a little bit, right, to say something like, which sport do lot of short people feature in? And if I change this question a little bit more to say, which sport is dominated by short people featuring in events? These are 3 different questions phrased slightly differently. Can you see what's the difference? Actually, for this one, it's a lot easier if you guys can talk, right? Instead of actually typing. Whoever wants to voice your opinion, feel free to talk. Is there a difference in these 3 questions? Darren, any thought? Okay. Okay, that's a good point. So let's see first, what's the first question? Which sports do short people feature in a lot of events? So first, we want to see who are short people. Anyone whose height is less than 175 centimeters is a short person according to us. Right, so these are all the short people events, 98,000 things that short people participated in, right? Now, which sport do most of them, do a large number of them show up, right? So I say group by sport, and then I count, right? So I should get the counts of how many, and I can only select 2 columns. I don't have to select so many columns. I'll just select 2 columns, which is height and sport, so that I can see easily. So these are all the number of short people who participate in each sport, right? There are 3,440 people who participated in alpine skiing who are less than 175 centimeters. Whereas in lacrosse, there is exactly one person who participated who is less than 175 centimeters. Polo also has just one. How about gymnastics? So this is the first question, right? But does this tell you how many different people participated, or does it tell you how many people how many events did people participate in? What does this number tell us here? How many events, right? So it is possible that there is exactly one short painter who participated in all the art competitions, right? So here I'm counting the same person many times, even though height belongs to a person, right? Like a person has height, but here I'm counting the same person many times. What if I don't want to count the same person many times? But unique of what? So if I do unique, I'll get unique heights here in this case, right? I'll get just unique heights or in unique. So, but this is even more meaningless, right? All it is telling me is there are 24 different heights less than 175 centimeters. So the dot count was telling me how many different people participated. So now I really, if there are multiple people in the same event, will it count it as only one? No, it's not counting it as only one. So let's look at art competitions, for example, because it has only 21 events. Let's see, of these, I'll say complete events of sport equal to this art competitions and this. Uh, Okay, let's put a parenthesis just in case if that's what's causing this thing. Oh, maybe I have some mistake. Sport cannot perform random goal. Okay, so let's just do this way. So first I'll just pick height and sport from this. Yeah, we'll find out 1 second. So off this. Oh. So I found out all these. This I'll say is, and I will get the name of the athlete and name of the ID. So these are all the short athletes, short athlete events. Now in this, if I want to filter out by sport and say only art competitions, oops, maybe typing mistake. Okay, so these are the 21 people who participated in art competitions who are of less than 175 centimeters. If you notice, this is the same guy, right? These two are also the same person because the ID is the same. Because this person participated in two different events. If we look at all the other columns, so if we look at all the other columns, we see where the differences are probably. So this guy participated in 1924 Summer Olympics in sculpturing. What's the difference? Some column must have some difference. Let's see. Maybe there is a different, maybe he participated twice in sculpturing, right? Maybe he has two sculptures that he gave for the competition. So that's possible, and that's why they are showing up twice. He didn't get a medal, probably not. Now I'm just talking about like athletes in general. not medalists alone. So this is showing us that we are getting the same people twice. Now we want to get the same people only once. The first thing I want to do is I want to group by sport. I want to group this by sport so that I can find out which sport has the most number of short people participating. So I'll sort this by value. I should say count for this guy, not for the actual data frame. And then we'll sort these values. So that really doesn't matter much. Now I'll reindex this data set, reset this index. That will give me something like this with each sport. Let's just pick like some columns so that I can see what's happening. I'll just pick sport and hide. So each sport, there's just one person here, 21 people here. Now this is sorted by number of people who are short. So if I say ascending equal to false, this will show me how many people who participated here. But this is counting the same athlete multiple times, right? Based on what we already saw, this is counting the same athlete multiple times. But if I only wanted to count one athlete once, then what should I do? Any thoughts? If I want to count, so let's take our previous art example itself. This is short athletes and then oh, if you just group by, it will only show you that. If you only group by, it will just say that. So I got my 21 rows. I got my 21 rows, which are just short athletes in art competitions. Now I want to only pick each name once. How do I pick each name just once? Dot unique. Okay, but dot unique gives me what? Dot unique gives me an error. It's a dot unique is not really working out. Dot n unique. Okay, dot n unique. Give me some random things. Okay, of id dot n unique. Or okay, of id dot unique. Okay, let's see what that gives. So it now gave me 1, 2, 3, 4, 5, 6, 7, 8, and 13 values. So now it gave me 13 values, but I sorted this and said for each sport, I want this short athletes, right? Now, how do I do this for all sports? Okay, I removed that and it gave me this. What does this tell me? This doesn't tell me like which sport has how many short athletes. So I'll take this. So this is with the second brackets. This now gave me all unique short athlete sports. From here, I'll drop duplicates. Right? Does that make sense to drop duplicates from here? If same guy participated in the same sport twice, I'll just count that guy once. Right? So now this has same event or unique athletes, right? So now I have unique number of athletes who participated in a given sport. So now I can group this by sport and then count. So that's how I got those sums. Now, if you look at it, gymnastics only has 2,108. Okay, let's sort this also. Sort values by equal to ID, ascending equal to false. Previously, what did I get? Gymnastics was the sport with the most number of short people participating. If you look at in terms of actual people, gymnastics has like the fifth most number of short people participating. Athletics has a lot more. What does this mean? There are 2,108 people or 2,108 gymnasts who participated in 17,000 events. What does that tell you roughly? What falls into the category of athletics? I think all of the things that you would normally consider athletics: long jump, high jump, runnings, like, because there is no other thing here for running or anything else. It's just all of them are athletics. So there are 17,586 gymnastic events where short people participated in, but there are only 2,000 short gymnasts. What does that tell you roughly? Any thought? Many of them repeated, right? Like at least on an average, each short gymnast is participating on an average in 8 events, right? So 17,000 divided by 2,100. Whereas in athletics, there is only about 13,800 out of 7,800 athletes. Right? So in athletics, short athletes don't participate in too many events on an average. Most of them are just participating in 1 or 2 events. And that makes sense, right? Like if you are in running, you would participate in maybe 100 meters and 200 meters. You wouldn't participate in running and long jump simultaneously. Same athlete wouldn't participate in 2 different events of like that. But if you are in gymnastics, and if you are really good gymnast of Olympic caliber, most of them probably participate in 5, 6, 7, 8 events, right? Does it make sense? Is this clear? Okay. So what did we do? We basically dropped duplicates so that we get each person once. Here we didn't drop duplicates. We got everybody the same number of times. Now, if I ask the third question, which is, which sports are dominated by people who are short, right? If I say that one, which sports are dominated by athletes who are short, how do I do that? I should then calculate how many of the athletes are short athletes, right? So I do the same thing as here, but instead of doing it as by all sports, I would just do all athletes, right? And then I'll group by sport and count the same thing. And let's see what this gives us. So in athletics, there are 22,000 athletes. Of them, 7,000 of them are short. It's so 7,000 short athletes out of 22,000 athletes who participated in Olympics. Does this mean athletics is dominated by short people? Any thoughts? No one has any. If no one has any thoughts, then maybe we'll just skip this and go to something else where you might have some thoughts. Okay, I'll randomly pick someone. I'm confused on how do you do the plot for the number one? For which one?
Maybe we should find out which country has won the most medals.
Okay, you want to find out which country has won the most medals. So how do you find out that one? Which country has won the most medals? First of all, what is the answer? Which country has won the most medals?
I'm not sure. That's what I want to find out.
I mean, it's kind of okay. So probably USA. Okay, so 2 USA. Okay, let's see. So how do you find out which country has won the most medals? So first thing you have to forget the list of you have to get the list of medalists, right? So this will give you the list of medalists. Oops. Is not. So this gave us the list of 39,783 medalists. Now of these, you have to group by, you can group by country. If you group by country, it will tell you which country has won how. Oops, there is no column called country. Okay, let's see what's that column called. Team, maybe it's called team probably. Okay, so now we want to see the count. I'll just select one column from here and I'll say group by, I'll just pick team and medal. And I have to sort this by number of medals descending, right? Right. Darren, value counts will work when you have one column, Darren. If I ask you something like, which country has the most number of female athletes who won medals, then you wouldn't be able to group by, right? You can't count with value counts anymore, right? Oh, did I do false? Yeah. I think I put one little here. Okay. So US has Okay, not sure what's happening. My laptop is rebooting randomly. Pawan or Balaji, can you let me present? Okay.
Are you okay now?
Yeah. Got. Okay. I'll try to connect from another laptop if this happens again. So let's see what was Jonathan's question. The question was, which country won the most number of medals? Right. So answer obviously based on this is United States. Now, if I want to find out which country won the most number of bronze medals, or which country won the third most number of bronze medals, how do I do that? Maybe instead of just finding out gold medals or total medals, I want to also find out how many types of medals did each of them win also. That's a reasonable question to ask, right? No, I don't want to just ask bronze medals, right? Like, so what if I ask that, then next question immediately will become, so I just want to know, like, by country, how many gold medals, bronze medals, silver medals did they win?
I want to find out how many total medals.
This is the answer already, right? US won 5,200 total medals.
Like,
so we
all medals, gold, brown, silver, doesn't matter. As long as it's a medal, it counts.
Yes, and this is the answer, right? Like, so for that, you can actually even do with a slightly lesser long query. You can even do with this few shorter lines. You can count by value counts for a given team. So you can do something along these lines. So you can say dot. So this was what Darren was saying, right? Like, Darren, that's what you were saying, right? If I wanted to just count how many total medals were there, I could just count value counts, right? But if I want to count more than just that, so if I want to count, let's say, how many gold medals, how many bronze medals, how many silver medals did they find? So why stop there? Because there is no reason to stop only at the total medals, right? No. Again, you're assuming this is separate questions. What if I want to give how many of these 5,219 for each of these totals? How many of these are gold medals, bronze medals, silver medals? Do I need to write 4 separate statements to figure out that, and then do what? In this instance, I really want to figure out what's the distribution. So 5,219, of that are 3,000 of them gold medals and 2,000 bronze, silver medals, and just 19 bronze medals, or 219 bronze medals, or what? How do I do that? Yes, Vidyut. So what does count do? So do you understand till this part what happened, Vidyut? Till this part? Till here we just got the list of teams there, and where list of IDs. So basically unique as athlete ID, their medal, and the team. Then I group by team, right? So what this means is basically I'm trying to take this data and stuff it into different buckets. One bucket is for team Denmark/Sweden. One bucket is for team Finland. So I'm trying to put it in different buckets. And then I'm counting how many things are there in each of those buckets. So then I'm counting each of those buckets, how many values are there. Then I have this sorting the values, which basically is sorting by number of values in those buckets. Does that make sense? So count is telling me each bucket, how many items are there or how many people are there. And then I'm sorting by total number of medals. So now if I try this, right? So now it is grouping by two things, right? So US won 2,474 golds, 1,512 silvers, 1,233 bronzes. Does this make sense? So now I've grouped by two separate columns. So I got the individual details as well without having to do two separate queries. So I know now US has won these many gold medals, bronze medals, and so on. Does this make sense? Oh, that's a lot of dots, yes. But there are only 783 rows. Oh, here. Yeah. No, you wouldn't do like this, right? So you would do something like groups equal to, and then say groups dot count. This would be more standard. In fact, you wouldn't even do like this. You'd first get medalists. So you'd first get medalists, right? And this is all the columns for medalists. And then we'll say grouping medalists. That would be medalists.groupby. And then you would count medalists in groups. So you do in steps like this, and then you would sort this thing. This is how you do. You would actually not do all of that in one line. You do it in 4 lines. So first we got the list of medalists. Then we are grouping that by team and type of medal. Then we are counting how many values are there in each of them. And then we are sorting it. Does this make sense? Like how we went through? Now, there is a very powerful thing that you can do. There is another way you can do this instead of sort. You can also do size. I think then you can't do this. You can do size, which is the same as count. It tells you how many items are there. But then you can do one more interesting thing called unstack. This now tells you as a new table, right? It now gave you a new table. So it now gave us a new table in which we have team, bronze medals, gold medals, and silver medals. Here you can add up the total medals of that particular. You can even count total medals from this very easily. You can say country dot sum of x is equal to 1. I think that should do it. And now if I display this, see now I got how many bronze medals are there, how many gold medals are there, how many silver medals are there, and how many total medals are there. Now I can sort this by whatever we want. So I can sort this by total medals, which is what Jonathan had originally asked. Right, if I sort this by and ascending equal to false. So if I sort this by total medals, I get United States at the first place. If I sort this by bronze medals, I still get United States in the first place, but see who goes to second place. Right, Germany, but Germany was not like in second place by total medals, right? So if I take this same thing and sort it by total medals. So in total medals, Germany was in 3rd place, but in bronze medals, they are in 2nd place. Unfortunate people. They are winning more bronze medals than they are winning. Since Soviet isn't a country and has split up, can we display the values of the country that has now split up? What do you mean by? Oh, you want to add up all the countries that came as that, like all the countries that were formed by splitting from Soviet Union into Soviet Union bucket? Is that what you want to do? Wow, that's interesting. So which are the countries that were formed out of Soviet Union? Does anyone know? Okay, let's see. That's a good question. Let's see. Okay. Oh, what's happening? This is called team. So these are all the unique teams in our data. Oh, we have a ton of teams. So let's start picking all the teams. Armenia. Okay, was Armenia? Let's see, Soviet Union countries. Hopefully. Okay. Let's go to Wikipedia. Hopefully they have it as a list. No, let's just stick to 1 or 2 things because it takes a good amount of effort. Wow. Even with this, it's a little bit of an effort. So let's just pick the ones that got created in 1992. Okay, so that were formed from Soviet Union. Okay, 15 republics. Okay, we'll just stick to those 15. Okay, someone already gave an answer. Thank you. So let's see if we can find these 15 in this data set. So unfortunately, there is no. I don't know if these are the same names in this table, in our table, but assuming they are the same names, I can see Armenia here definitely, but I don't see. Is there Azerbaijan? Do you guys spot it? There is Azerbaijan. Let's do it. Belarusia. It's probably called Belarus, right? And then Russia is probably definitely called Russia, right? We have to first know this list, unfortunately. Yeah, Belarusia is probably Belarus. Russia is Russia here. Oh my God, there is Russia, Russia 1, Russia 2. Just to make things complicated. So Russia is Russia, Russia 1, Russia 2. Let's see if Ukraine is Ukraine 3, 4, 5, 6, 7. Ukraine, can you see? Okay, Ukraine is Ukraine, Ukraine 1. I have no idea what's the difference. Maybe some years they participated under 2 flags. I have no clue. This is actually sometimes the problem with data, right? Like sometimes there is a East Germany. Yeah, no, I don't want to worry about all those. With it. We can try to merge those also, like East Germany, West Germany, but it will be too much of exercise. because Yugoslavia also has split. There are so many countries that have split. It's actually not that uncommon to have split countries. Uzbekistan is just one value. It'll just take time. I'll be wasting typing time. That's all. You can do this. I'll show you how to do for one of them. You can do it at your pace, how to group other countries. Plotting. That was what we'll learn. But because someone asked a very interesting question, I'm just going over that question. Then we'll start plotting. Kazakhstan is also just one country. Seaborn, if you are so interested in knowing which library. Okay, that's just one country. Moldova. Where is Moldova? Maybe Moldova. Okay, Moldova is also there. Turkmenistan. There is. Do you spotted Turkmenistan? No, right? That's not there. Maybe they never won a medal. That's possible. Tajikistan was there. Latvia was there. Okay, so now these are all one country. Right. So now what do you want to do? Whoever started this topic, what do you want to do with this? No idea. So now what should we do? Why did we waste this much time? So we want to say Soviet Union countries, right? So if Soviet Union was a single country, how would it have performed? That's what we want to see. So these are all Soviet Union countries. So now from our countries by medalists, we want to add up all the Soviet Union countries result. Right? Oops. Oh, did I not run these things? Okay, so this one. I'll just do reset index. So now I have, oh, did I have many levels? Okay, fine, whatever. So now in this data set, why do I need reset? Because I wanted this team to come in. I don't need reset index in this particular example, actually. It doesn't really do anything different. Let me just stick to what the original index was. So this is sorting by something, right? It's sorting the 497 countries in this data by something. If I don't want it to sort by that thing, first I reset index so that it will come up with some random thing and I sort. I can also achieve that by this. I can sort by total medals. And you, but it's still calling this medal. It doesn't, it's some random column. So now what I want to see is within this data set, I want to filter team is in Soviet Union countries, right? So I want to get all of these things. There's something that's going on. Let's see. Is there wrong team? Okay, what is the type of this thing? Let's see. Oh, maybe it's not complaining about here. I have a chat window that, oh, I didn't close this thing. Ah, too bad. Team is in this list of Soviet Union countries. So now I just want to get the list of these guys. So these are all the countries in under Soviet Union. Oh, and I should also include Soviet Russia, right? So Soviet Union should also be part of Soviet Union. So now I got all these. Now if I want to add up all of these numbers, I would just do sum and that's it. This will now give me, oh, this is because I have grouped based on so many things, dot sum of axis equal to 0. So this is how many medals that country would have won if it was. So this is just axis equal. So if Soviet Union wouldn't have been divided into smaller countries, they would have won 4,190 medals. They would have been still second place. Does this make sense? So this is an interesting exercise if you want to continue, right? Maybe what you should really think about is, here the country is actually not really a meaningful country, right? It's sometimes broken into pieces. What is Russia 1, Russia 2? So try to group these countries. So add a new column to your data set, right? So you can add a new column to your data set called country and say, set that to whatever you would consider it as the country, Soviet Union, right? So right now I'm setting the country to be Soviet Union for everything, everybody, irrespective of which country they belong to. But you shouldn't, you should filter and do this, right? If you add a country like this and you filter, then you are getting a true count. So this could be an exercise for you to actually group by countries, add a new column to the data set called country, and use countries that are known, that will group things together. See, what is this A North American team? I have no clue. Alibaba 2, right? What's Alibaba 2? Since we don't know what these are, you can even drop if you don't know. Amateur Athletic Association. If you don't think that these are countries, just drop them. And then you can do this exercise to like see, figure out which country did, how did each country perform. So that would be an interesting exercise. So what did we go over? We went over how to find out simple question, which is total number of medalists, which you can do very simply using value counts. But we tried to do a little more complex thing. This is called a pivot table. For those of you who are not familiar, this is called a pivot table. We created a pivot table based on team and based on the different types of medals that each team has won, and added total medals as a column to that pivot table. This unstacking thing creates a pivot table. This is a useful way of looking at data. Does this seem useful? Anyone, does this seem useful, or does this seem like it's just a big way of different way of looking at data? I don't know what country this is. Anyways, now let's look at a couple of plots, and then we can take a short break and then come back. So now that I have this data set or data frame, I want to plot this, right? I want to plot, let's say, a line plot, which is the default kind of thing. So I'll just call plot. It has plotted the total number of medalists on this line, right? In this, what is the x-axis, what is the y-axis? I can say plt dot x-axis, x label is the country ID, and plt dot y label is the number or total number of medals. So this is just a country ID and this is number of medals. Does this plot tell you anything at all? Can you tell me which country won the most number of silver medals, most number of bronze medals? You can't. You can't tell anything, right? All you can see is one color. Oh, it is actually plotting bronze and gold and silver, everything. You just can't see. Let me change the size. I think it's this property. Can you see tiny green bars here? Like in this, if I zoom in, maybe you can see. Do you see small greenish thing and small brown, bluish thing and small orangish thing here? So it's actually plotting all of them. Just because total medals is larger in number compared to the bronze medals or gold medals, it's just you're not able to see anything in this graph. Right, so see here it's saying in this legend that it is actually showing all of those. Bronze is blue color, gold is orange color, silver is green color. So let me see if I can just plot bronze medals, gold medals, and silver medals. Let's see if I just plot those three without plotting. So now you can at least see some colors, right? You can see some yellow, orange lines, some green lines, and some blue lines. Kind of, at least you can see some different colors at least now. Ideally, we would probably just want to start with one color, see which country won the most number of bronze medals, right? This seems more reasonable in color at least. Where each medal is a different bar. Yeah, we can try. So first let's make this x-axis team so that we will also see somewhat meaningful names. But there are so many names that it can't actually show all those names. It's only showing, otherwise your chart will just be filled with names. Maybe let's just do like a 7x7 chart so that it can be displayed in one screen. So this, while it shows here, this is not really that meaningful, right? So like Darren asked, let's now try a bar graph. So now I got bar graph. Can you see what's happening here at the bottom? Exactly. And why is that happening? Too many names. Exactly. There are almost 400 names. It's trying to plot all that in such a small graph. So let's say I make it 30. It'll still be a lot of mess. But at least it'll be, some names will at least be visible. Now you can at least see some more names, right? But it's still a mess. So this is our focus now. In the next 1 hour or so, once you guys come back from the break, we'll focus on how to visualize data like this, right? We'll first go over a few simple plots, and then we'll try to see how to visualize when you have so much data, when you have 500 different teams, how to even make sense out of this data? It's just 500 bar graphs, won't do any good. So your two objectives, go over different types of plotting and try to figure out how to show this in a meaningful way. Okay, let's take a quick 10-minute break. We'll be back by 11:15 in Pacific time. If anyone has any questions, we can go over those. You don't see this plot. Oh, I don't know what's happening, to be honest. Maybe you have to keep refreshing. I have no clue. Okay, are you guys back? Okay, so while you were away, I just grouped these things a little bit. You can go over it later. Quick review of what we did. We did homework review, then we extended the homework problem a little bit. Because what happens in data science is how you define something matters a lot, right? Same question asked slightly differently could actually mean completely different, or similar sounding questions may not actually mean the same thing. So that's what I was trying to show in this. And this is something that is very common and a big problem in data science, right? When someone says, let's say, United States is the country with the most number of medals, followed by Russia. Actually, you guys might have heard of this controversy this year, right? Like China won more. Who won this year's Olympics? Right, 2020 Olympics. So obviously here the winner was United States, right? If you look at this table, right? It looks like US won the Olympics. But what China did is they went and where is they found a very tricky way to sneak in certain things. They tried to add all the medals that were won by countries that they claim are theirs, like Taiwan. Where is Taiwan on this list? And then they said, hey, we won more gold medals than anybody else by doing this addition, wherever that country shows up. So they claim that they were the winner of this. Right? So both of them are data-based. Both are based in data. Just how you slice and dice the data gives you different answers. So that's what we saw here. So if your question is to figure out how many short people participated, like in how many events, that's one answer. How many short people participated, that's a different answer. Which sport is dominated by short people, that's a completely different answer. Just to illustrate this, when I run this, you can see that gymnastics has the most number of events in which short people participated. Whereas athletics has the most number of short athletes who participated. And finally, rhythmic gymnastics is a sport dominated by the most number of short athletes, right? Trampoline is also dominated by short athletes, synchronized swimming, softball. Neither gymnastics nor athletics comes anywhere at the top. All of them are answering the same kind of question, but slightly different, right? And this is a common problem in data science. Hence, you should really try to check how your question is framed, not just what the answer is about. You also have to worry about what the question is talking about, or what kind of thing do you want to look at. Then we looked at some powerful concept called pivot table. This is more powerful than value counts, which is what we saw previously. If you wanted to check how many countries won medals, that's one country and one number. So just two columns, that's relatively easy. But if you want to extend that idea beyond that, this pivot table is a convenient idea. And what we did here is we created a pivot table with the team, number of bronze medals, number of gold medals, number of silver medals, and total number of medals. However, this came up with its own mess because there aren't 498 countries, right? So you need to group countries. And this is an extension of how you can do that. You can identify your own column called country and start assigning things. Start assigning a country that will clear up that mess, right? So you can somehow bring this data back to more meaningful things. Finally, we started with some plots. Irrespective of the plot, when I plot the number of medals for all the countries, it just looks like a big mess. So that's what we did in the last 2 hours. Now we'll spend some time in reviewing what the different plots are. So first thing we'll look at is what a general plot is. Once you have data in a data set, right? Once we have our data. So tell me some plots that you would like to see, and then we will try to see which thing makes it easy to see. What's one kind of plot that you guys would like to see?
I want to see a stem and leaf.
No, I mean not that one. What do you want your plot to tell you, right? So what kind of plot, in the sense, like here we were plotting to see which countries won how many medals, right? So here we have, these are our data columns. Which columns do you want to see plotted? And then we'll see which kind of plot would give us a better picture of this. So someone said line plot, so I'll just start with line plot. How many medals did a specific one country won each year? That's a very good plot. We'll get to that one in a second. So first, let's plot whatever Shruti asked first, which is the simple one. So let's just say I want to plot age. Does this look meaningful? Histogram, good point. Someone already went to that direction. So when you want to look at age, this is a line plot. This is what is called as a line plot. Okay. So line plot. is only good when you have small amounts of data and want to see how the data is trending. Also kind of only makes sense when you have that data sorted in some sense. Right? So if you sort this data by age, and let's say athlete events age, it could probably make some sense to plot line plot. Wow, even then it doesn't really make that much sense. It's going all over the place. So let's say ascending equal to true. No, still no use. So it really doesn't seem to make much sense, whatever direction I plot. So once you have too much data, we'll get there. So once you have too much data, it really tells you almost nothing. So the next thing that Darren already pointed out is, let's see first if we can plot a bar plot with the same thing and see what happens. So with pandas, one of the easy thing is you can put just this simple thing, data frame dot plot, and which column you want to plot. It's just as simple as that. And you can put a comma and say which type of plot you want to plot, right? I can say bar plot. Let's see what it plots. I think I should change my runtime to, yeah. I shouldn't have tried a bar plot because there are too many bars. That's why it's struggling so much. I should change my runtime to use GPU, which will disconnect my data. Oh, so for those of you who just saw what I was doing, in Collab, there is this menu called runtime. If you choose change menu type, there are different types of menus. Normally by default, it is chosen as none. What that means is it's using a CPU like on your laptop, right, to do all the calculations. Certain calculations can be done in parallel, especially when you're drawing a plot, right? When you're trying to draw a bar graph, I want to know what's the height of each age, for example, right? If I want to know that, I can go and calculate, split my data into groups and then calculate what's the sum count in each group in parallel, right? I don't have to count all of them in one place. I can split the data and make one processor count for 20-year-olds, one processor count for 21-year-olds, and so on. So when you have parallelizable processes like that, you would benefit by using something called a GPU or graphical processing unit. If you do something, if you start using a library called TensorFlow, which takes this to a little bit more, stretches a little bit more, you would use something called a TPU, and that would even make your calculation slightly faster. So in this case, I'm choosing GPU because all I need is like some plots. So it will be slightly faster. Not slightly faster, sometimes dramatically faster, sometimes slightly faster. So looks like a bar plot is taking too much time. What's happening is we have a lot of data, first of all, and it's trying to draw bars like this, right? It will also draw something similar here. There wouldn't be that much of a difference with bar plot. It would also draw something like this. So I'll just stop this because it's almost a minute now. But what kind of plot would have made this clear, right? So if I want to see like age, this looks like a very noisy plot. What kind of a plot would make it look nicer? histogram. Okay, so let's try a histogram. Let's stop this cell. Line plot. This is a line plot with you. This is a line plot. My line plot is not telling me anything. Let's see what a histogram tells you. Okay, does this look more cleaner? So what is this telling me? That's not really a bar graph. It's a histogram with bars in it. What this is doing is, let me explain. So this is the second type of one, histogram. This one, it didn't even complete. So what is this histogram doing? It's splitting the data into buckets. If you can see here, 10 to 20-year-olds, right? In our example, we are splitting age into buckets of 10 years each. That means we are doing 0 to 10 years old, 10 to 20-year-olds, 20 to 30-year-olds, 30 to 40-year-olds, and so on, right? So looks like there are no 0 to 10-year-olds. That's why there is no bar near 0. And then there are 10 to 20-year-olds, 20 to 30-year-olds, 30 to 40-year-olds, or maybe it's doing in fives. I don't know. I can't tell here. I should check, but I think it might be doing it even in fives, 5 years each. So 10 to 50, 0 to 5, 5 to 10, 10 to 15, 15 to 20, and so on. So it's plotting how many athletes whose ages are between 15 to 20, 10 to 15 did participate. What does this tell you from this plot? What can you tell very quickly?
Most participants are at least 20 years old.
Are between the ages of 20 to 30, 25 probably, right? Maybe 20 to 25, 20 to 30, right? So that's something that's a very insightful thing. When we drew this kind of graph, when you drew a line plot, could you tell the same thing? You couldn't tell anything, right? Compared to that, here within one shot, you could tell that. This is what is also called as data distribution or empirical distribution, right? So histograms tell us the distribution of the data, and they're very, very helpful. But what if I don't want to group by 5 years in 5-year chunks? What if I want to group this into 10 buckets only and not 20 buckets? Right now, this seems to have grouped into a lot of buckets. So there is a convenient way. You can say how many buckets you want to group into. Let's say I want to group everything into just 5 buckets. So now it grouped everything into just 5 buckets, all the athletes into just 5 buckets. Does this make sense? If you have more buckets, will the program be faster? I don't know. I don't think so.
If you have more buckets, if you have like more data, the program will probably be slower.
Right. See, I tried to split it into 50 buckets, basically every 2 years, right? Because my data is between 14 and 97. How do I know that? We already calculated that. So, okay, between 10 and 97. So I'm breaking that data into 50 pieces. So every 2 years roughly, right? Or every 1.8 years worth of age. And now there are 2 lots of peaks, right? So this is also a histogram. This is also a distribution. This tells us something slightly different. As we break them into more pieces, right? Yeah, less buckets. So if I break them into just 5 buckets, that means each bucket is of uniform size. So 87 divided by 5. How much is 87 divided by 5? $17.4, right? So 17.4. So each bucket is of size 17.4. Then this distribution looks like this. When each bucket is of size 1.87 divided by 50, which is roughly about 1.74, it looks like this, completely different distributions, right? They are both distributions, but they are telling you slightly different things. This is a very powerful thing. If you wanted to count how many young athletes, old athletes, you could have used this. How many short athletes, tall athletes, you could have used this very quickly, and you could have seen, you could have gotten a lot of insights into the data, right? So histogram is a very powerful data visualization tool. Any questions? Useful in getting insight into what frequency. Yeah, we'll come to scatter plots. Those are, yes, what is recommended bin? We actually have no clue. It depends on the data and the purpose. In getting insight into how frequently data values between certain ranges occur. So for those of you who have studied probability, this is also called probability distribution. So this is plotting the probability distribution of this data. So very powerful thing. Okay. What is the recommended bin? There is actually no recommended bin. It depends on what you're trying to do. Like for example, if I want to calculate old athletes versus young athletes, I would probably just split my data into two pieces, right? So if I'm trying to do this, I would probably just split based on age into just two pieces. So it split at like 50 years old, right? It split the data evenly and said 50 years old. There are very tiny number of athletes more than 50 years age. So it just depends on what you're trying to look for. But it's a good way to start. So when you have a data, you should start with, you can start with the plot of the data, which will give you, or one column, right? Which will give you what that one column looks like. If you have small number of values, you could even go for bar chart. Let's try like picking a small number of values from this. So let's say we just pick the top 100. And then we'll try to do a bar plot on that. So still not very clean, right? It's trying to, it almost looks like this line plot. It's just doing those bars instead of lines. So again, slightly insightful if you have small amounts of data. Once you have large amounts of data, it doesn't do that much unless you start grouping things like this, right? So histogram is the first meaningful plot that you could use on large numbers of data. Without grouping, of course, you can group these things, right? You can group these things and get some insights even with this. Then which plot? Pie chart. Some of you or all of you may be familiar with pie chart. Do you know what's pie chart? Right, a pie. Right. So which sections divided? Absolutely. So now let's see with our data. If I draw a pie chart, what happens? Now, actually, I want to draw with a different column. Which column should I draw? So which column do you want me to explore drawing? Countries and medals. Okay, let's try that one. So first you have to calculate the data set, right? So for pie chart, we want to plot a pie chart of countries and number of medals they won. We already calculated it above, but I'll just do the easier way, which is get the medalists and then of team dot value counts. So this will give us a series. I want to convert this into a data frame. So what are the columns in this data frame? And then I'll reset index. So now I calculated something where I got index. So I have to rename this column called index. Column index column should be renamed as country, and team column should be renamed as number of medals. Oh, I should have done it in place. And now I have my data set, right? So first I prepared the data. I got the team and the number of medals. This took some preparation. Now I'm going to plot. So I need to tell it which column. My Y is number of medals. Oh, and I should have told it an X column also. Okay, so now it will plot a gigantic pie chart with a lot where the legend is so long. I hope you can see something from this. You can see, oops, it's not plotting. Okay, 1 second. Let's see. Label or position only use this data. 1 second. Let me quickly see. Let's just pick the top 10 countries or so, then we can make sense out of this. And some of these plots are really bad because we have too much data, not because the plot themselves are bad. So let's just pick first sort by values. We'll sort by number of medals. And then I'll just do it with the first 10 rows. So let me see what my data frame is. I should say index country, not. 1 second, I'm just trying to figure out which parameter should I set to get the country instead of the. I probably don't have to reset index, so I don't have to rename this thing. Yeah. Number of countries. Oh, I should have sorted by ascending false. So this shows a pie chart. Let's make it a figure size a little bit bigger. So this shows a pie chart where United States is the dominant one, Soviet Union is the second most, Germany is the third most, and roughly the size is showing up, right? Does this make sense? This shows some data now, right? And you can tell what's happening at least. So it was a relatively quick thing that we could do. We calculated the value counts for each team. We renamed the team column to number of medals just so that, oh, no, that's my mistake. So I made a mistake here. That's why it was not team. I should have renamed the medal to number. One second. I renamed the columns incorrectly. That's why I got such bad data or seemingly incorrect one. So df.reset index is equal to true. So first I should rename my columns in such a way that index becomes country and team becomes number of medals. So now is my data frame looking correct? Okay, now I'll see if I do this. Sort by number of medals and let's see. Okay, now. So it's only plotting by the index of that column. So whatever is the index, it's going by that. So, okay, let's stick with this one. First, I calculated for each country how many medals it won, and then I renamed a column called team into number of medals. I sorted by that, and I'm just plotting the top 10. So it has just the numbers. So what I did, Shruti, is basically I didn't reset the index. So in the pie chart, oh, if you don't plot also, you'll just get the same thing, right? You can do this way. You'll get the names eventually. There's no problem with the names. If I don't plot the top 10, you'll get it. It just will look very hard to see. Right? So there is a chart. Let me see if I can set the legend aside. Switch off the legend. Let's see. Okay, so I probably have to get it into an axis and then say axis dot legend location equal to n. No, axis is not defined, so really worth it. Yeah, I don't remember the exact syntax, but we can separate out. Right, we don't need legend. I'm just trying to figure out how to suppress the legend. There seems to be no shortcut. Let's Google and say pandas pie chart suppress legend or remove legend. Pandas pie chart remove legend. No, not what we want. Everybody wants legend. We want no legend. So my labels, colors. This is with Matplotlib. Yeah, I'm not sure. Remove access legend. Let's see. Where did they remove? Oh, legend equal to none. Maybe I can try that legend. This way. No. I don't know if this will do it, but let's see. Okay, so it removed the legend and we got a nice pie plot, right? Pie charts are also only useful when you have small amounts of data. Otherwise, you can't really see anything. I don't know if you can see anything in this last zone, just like tiny, lots of tiny streaks. But this still tells you that USA, Soviet Union, Germany are the top countries who won medals. Even if I increase the size of the chart, you'll see more clearly, but it's not going to make it a lot more nicer, right? It'll be, now it's 20 by 20 inches. Still super hard to tell, right? Can you see here this noise? Right. So pie charts have become a little bit unpopular these days because of two reasons. Used to show a percentage of the total for each data point, right? So it's almost showing like the percentage. It's saying United States won this much percentage of the total medals. That's roughly what it's doing. But it's unpopular a little bit because you can't tell what's the percentage, right? Can you tell what's the actual percentage? No, right, from this. And if two things are close, like Netherlands and East Germany seem like they're close in width, and Japan, they're close in width. You can't exactly tell. You can calculate, sure, but the whole point of plotting is to be able to look and tell, right? But I can't tell exactly, is this really, are these three almost the same width or not? I can't tell exactly by looking. I can tell that these two are not the same width, but are these two the same width? Very hard to tell visually, right? Does it make sense? I don't know if we can put like a pie chart, display percentage on us. Show this. Shadow effect, subplots. No, add percentage. Okay. So it says there is something called auto PCT. We can set it to true. So let's try that one. Maybe it gives us somewhat more. So now it's giving us the width of each of these. So Hungary and Russia are exactly the same percentage. Netherlands and East Germany are almost the same, but not the same. Japan and Norway are the same. So is China. Wow, that seems surprising, right? Actually, yeah, maybe China just became dominant recently. So this is another visualization. Now let's look at a couple of more of them. So pie chart, area chart. It's kind of similar in idea, but slightly, no, definitely not similar. They're different kind of idea. So let's take the same thing and plot an area chart. Let's see what it looks like. Oh, no country. Oh, no legend, no TCP. Can you see this? Or let me make this a smaller plot first. This kind of tells you, again, United States is dominant, and then slowly everybody in terms of the area. So same way, if I just do head of 10, this should tell you clearly the area, right? So again, kind of like how dominant is each country. So United States is very dominant. Germany is second or third in this case. Looks like a chair, yeah. So it's kind of showing you how this is declining, right? Topmost country, second top country, third country, fourth country, fifth country, and that's declining, right? So it's helpful to see, right? Helpful to see the relative decline of each unit. In place equal to true just means it will rename the column within this data frame and then assign it back to itself. Otherwise, I would have to assign it myself manually. So quick recap, we saw 5 charts, right? This is a line plot, this is a bar plot. And then we saw a histogram, which is the most useful one according to me so far of the ones we saw. And then a pie chart, which shows some good information, but very noisy when you have too much data. And then area chart, which is also noisy when you have too much data, but shows some good information. Even when you have a lot of data, we have 270,000 rows, right? So that's a lot of data. So even then it's giving us some meaningful display. Then the other 2 charts I wanted to go were scatter plot. That who was asking for scatter plot? Someone was asking for scatter plot continuously. Okay, Satvik. Okay, so plot of, let's say, kind equal to scatter, y equal to, what do you want to scatter? Weight, height, age. It has to be a number. So now let's try weight. Oops. It also needs an x-axis. So let's say height. So height versus weight, this is the scatter. What this is showing is how these 2 things are related to each other, right? As height increases, you can see that as height increases, weight increases also, but it is not uniformly increasing. So it increased almost like this and it is falling off, right? As height increases, weight increased till here, and then it's slowly starting to decrease, right? So you can take this outline and say, okay, height and weight are like related in that sense. Is weight in pounds? I think so, 220 kgs. Actually, it may be in kgs. Let's see, I don't know. That's probably in pounds, like the lowest athlete weighing less than 140 kgs would make no sense, right? Gymnasts weigh less than maybe 140 pounds. So yeah, this is probably in pounds. Does this seem to give you a good information? £50 athletes is strange. No, that's not. Oh, yeah, 50 pound. Oh, okay, sorry. This is the weight, right? Yeah. Yes, so probably weight is in kilograms, right? So weight is probably in kilograms. Shows us the relationship between 2 variables. Right? So this is a good plot because it's showing us the relationship between 2 variables. Then the last plot that I wanted to draw myself was this thing. It's called box plot. And let's do it for height. Right. This is a very interesting plot. Yeah. When you don't know how your data is behaving, right. So when you don't know how your data is behaving, this is a good plot to draw. So first, let me draw another plot so that I can illustrate what's happening with this box plot. Okay, so these 2 plots are kind of related in the sense that what this box plot is showing me is that this line that you see here, this bottom line, that's actually, let's start from this box. This box that you see here is showing us that 165 or 170 centimeters, only 25% of the athletes who participated in Olympics in different events. So only 25% of the athlete events data has a height less than, let's say, 168 centimeters, right? This corresponds to roughly 167, 168. You can see that, right? Like if you take this 160, less than 160, only 1/4 of the data is there. Is that visible here? Majority of the data is in the right hand side of this compared to this left hand side, right? Does it make sense? So 25% of the data is to the left of this number. And this is telling you what that number is. Sorry, it is roughly here, this number, right? So it's telling us this number, it is less than 100 and something, 168, 170. Let me draw a bigger plot. Maybe it will help us see. Right, so 25 percentile is roughly around 170. So this box, the bottom of this box is the 25th percentile. That means 25% of the data is below this box. This top of the box is 75th percentile. That means only 25% of the data is above this box, right? 25% of the data is below this box, 25% of the data is above this box. So where does this box coincide? So let's say 185 centimeters. What this is telling us is 25% of the athletes who participate of the events have an athlete shorter than 168 centimeters. And then 25% of the, or 75% of the events have an athlete shorter than 182 centimeters. What does this tell you? Within this 14 centimeter range, 50% of the athletes who are participating in the games are within this 14 centimeter range. So that means most people who participate in Olympics are between 168 centimeters to 182 centimeters, right? And this green line within this box plot is telling you that 50% of the events have an athlete shorter than, let's say, this is 175 centimeters. Yeah, median means 50%, right? So this is 25th percentile, this is 50th percentile, this is 75th percentile. Percentile simply means of all the events that are there, 25% of the events have an athlete less than 168 centimeters in height. 50% of them have an athlete less than 175 centimeters in height. 75% of them have an athlete. So half of the people are the short people. In our definition, yes, we were saying half of them were short people. But it's not half of the people. There may be like very small number of people and they may have participated in thousands of events, right? You should not confuse between percentile and percentage, right? If you take a standard test like AMC 8, you score 25 out of 25 on AMC 8. Your percentile might actually just be 95 or maybe 99. Your percentage is 100, but your percentile is not 100 because there are 1,000 students who scored exactly the same rank. All of you got exactly the same score, right? Does this make sense? So percentage versus percentile are different things. Percentile tells you of all the data that you have, how much of the data is falls into one bucket. In this case, our bucket is shorter than 168 centimeters. This is it. Shorter than 175 centimeters, this one. Shorter than 182 centimeters, this one. This also means 25% of the data have an athlete taller than 182, right? Before we go to outliers, you have to talk about what these lines are at the border of these things, right? So as I told you, 50% of the data is within this small box, right? No, the minimum maximum is just an ambiguous way of calling that. 50% of this data is within this small box. What I want to see is how many people are far away from this small box and how many people are within this small box, right? That's what I want to say. And for my purposes, so what's the question? How many events have an athlete who is not within the, who is too tall or too short compared to the 50% compared to the athletes in 168 to 182 centimeters long? Because this 168 to 182% of the, centimeter range tells me 50% of the data falls in this bucket, right? So I want to see how many of them are far off and how many of them are close by. And what do I mean by far off? It is 1.5 times this. So if I am more than 1.5 times from this line, then I am far off. What do I mean by 1.5 times of the interquartile range? So what do I mean by that? 162 minus 1.5 times 14, because this box only is of height 14, right? 168 to 192. So 14 centimeters is the difference in which majority of the athletes fall. So if I am more than 1.5 times outside of 14, or 182 plus, sorry, 165 plus 1.5 times 14. Yeah, what does IQR is just a word, right? Like, so what does that word mean? IQR or interquartile range. What does it mean? Why is it important? Okay, Satvik. Yeah, but why is it important? Why did we only pick 75 minus 25? Why not 100 minus 0? Why not 70 minus 20? What was so interesting about 75 minus 25 and not between 75 and 25, 50 and 50 and 25? That's what I'm trying to tell you, not words, right? Why things were chosen that way, not just what the words are. We divided the data into 4 groups. Bottom 25%, middle 25, next 25%, next 25%, and the next 25%. So we divided it into 4 groups. We'll go over for another 10 minutes because I want to finish this. We started. Now we are talking about, that's not really middle 50. Yeah, you can think of it as middle 50%. Yeah. So we are picking the middle 50% of the data. That means, so between 0 to 220 centimeters or whatever. This is the bottom 25%. This is the top 25%. This is the middle 50%. So I'm calling the middle 50% of the data as the average data, or the data that I'm interested in. And then I'm looking to see how many people are more than 1.5 times away from this direction and this direction. So 165 minus 21 or 182 plus 21. So that's what I'm calling this minimum and maximum lines. Why 1.5 times? Because it makes sense to have 1 time less, right? So if I'm more than this, then I'm calling that an outlier, right? If I'm outside of this range, I'm calling them outliers. So they are either too short or too tall compared to the middle people. This makes more sense if you think of it as scores in your class test. If let's say 25% of the students, so let's say there is an exam for 100 marks, 100 points. 25% of the students, let's say, got 25% of students got less than 35 points. 50% of the students got less than 60 points. 75% of the students got less than 90 points. And 25% of students got more than 90 points. Right, so this is how our distribution is. So let's say our class has exactly 100 students. I'll just say off instead of off. This is how I would get it. But there are some students who did much better than the average, right? Actually, in this case, I'll probably not get a good distribution. Let me pick short range. Yeah, greater than or equal to. So let me pick a short, narrower thing so that I can get something like this. Now this is my distribution. So 25 students got less than 35 points. But are there some students who are really bad? And then there are some students who are really good. 25 students got more than 75 points. Does that mean all of them are really good? Probably not, right? There may be still some really good students. If I want to find out who are the really good students, my criteria is saying if they got more than 75, but how much more than 75? At least half more than this range. So this range is 40. So in this case, if I do 1.5 times 40, 60. So 135 points. So let's say this test is for 150 points. So anybody who got more than 135 has done really well. If this test is for 150 points, anybody who got more than 135 has done really well. Anybody who has gotten less than 35 minus 60, in this case, nobody will get that because the distribution is like that. Anybody who got less than 25 has done terribly bad. That's my definition. Basically, I'm saying 1.5 times of the middle size. If you're more than 1.5 times away in any direction, you are either too good or too bad. That's the motivation. So that's what box plot tells you. In one shot, it's telling you so much information: 25th percentile, 50th percentile, 75th percentile, and people who are too bad and too good. It's a good plot, right? When you have a lot of data. Any questions on this box plot? Because this is the last plot I think I wanted to cover today. Oh, density. Sorry, I forgot density, but density probably looks similar to area in some sense. Let's see, where did I stop this? And I think density also makes more sense to. So this is also kind of showing you where is the highest. So it's telling you also kind of like a histogram. But the height here is not frequency, it is like the relative occurrence. So 0.04% or the 0.04 of this is here. If you add up the area under this curve, you get 1. So this is like the probability distribution again. So more like histogram, but continuous. So this is all the stuff I wanted to cover. Any questions on any of these plots, we can stay. Otherwise, I'll just describe the homework, like what, or I can ask you guys what you want to do. So last 5 minutes. So either you guys can pick a homework topic of your own. So you can tell me some questions and we'll pick from those. Plot age, weight, scatter, different data set. We'll go to different data set as part of a project, Darren, because I want to, if you go to different data set, then I have to, there is some good amount of time lost in familiarizing with the data set. We'll go and do a different data set, but more like as a project. So actually there is one more thing, it's called scatter matrix. Can we have some reading homework? Okay, sure. You can read about all the plots. Okay, so one question is reading homework. No, there are just 8 plots. So read about the 8 plots. And write when to use each plot. Show an example for each on our data set. Okay, that's first question. Good. So one reading homework. Any other ideas? Satvik, maybe you, so Satvik wants to plot scatter plot. Actually, there is also a very nice kind of scatter plot, Satvik. It's called scatter matrix. I think I have to import from some library. 1 second, I just don't remember exactly. From pandas plotting import scatter matrix. So this is even more of a powerful plot. And let's plot 3 things together. Yeah, it's an interesting plot. It's not commonly used, but it's useful. So what this is showing is, this is a scatter matrix. It's 9 scatter plots, age versus weight, age versus height. So this box on the bottom left-hand corner is age versus weight. This second box here is age versus height. This box here is height versus weight. So these two should look almost this. Oh no, this is height versus weight, and this is height versus age. So these two should look the same, just tilted, right? So this is height versus age. This is height versus age. And this is weight versus height. This is weight versus age. So these two should look tilted, and these two should look tilted. Okay, so these two are the same, kind of rotated little bit. These two are the same, and these two are the same. And these are the histograms of age versus age and height versus height and the weight versus weight. So it's a very interesting plot. This tells you how things are related to each other, or what kind of cumulative distribution or what kind of joint distribution do these variables have. It's a very interesting idea. So these are the 8 or 9 plots. So read about those 8 or 9 plots. Someone asked a question about plot, which we didn't do it here. Maybe you can try it as a homework, and you can send a message if you are, how many medals a specific country won each year, right? So that was Shruti's questions. Now, how many medals did a specific country win each year? API related homework we can do as a project, Satvik, I think, not as a homework. We can do as a project. I'm thinking about like giving some, okay, which kind of API? Actually, I was thinking about project ideas. One of the idea that I thought of was using some baseball data or basketball data. How many of you know or which sport is the most popular sport among you guys, so that I can think of some project ideas of the 10 people or so who are here? If you tell me what's your favorite sport, then maybe tennis. Cricket. Wow. Basketball. Oh my God. Cricket. Okay. Two votes for cricket. At least cricket is the winner so far. Okay. Only 4 votes. What about the others? Jonathan, any favorite sport for you? Darren, Jonathan, Meda?
Esports.
No favorite sport. You have to pick something. Pick some sport. Doesn't matter.
Like sports played on computers.
Fine. Whatever. Pick something. Which sport that is played on computer do you like, Jonathan? Cricket. Chess. Okay. Chess is a sport. Why not? Cricket works. Okay. Cricket. So we got so many cricket. Okay. But do you guys know cricket data, or do you just watch? Because cricket data is different from cricket as a sport, right? Do you watch cricket on television or like follow cricket on some website? Okay. Okay, let me see if I can pick some cricket data set and can give you a project on cricket. I'll probably give like 2-3 project things. Darren wants chess, cricket, basketball, tennis. Okay, let me think of some chess, cricket, basketball, tennis. Right. So your project.
Sports as well. Don't forget that.
Which sorry, what was that? What was it?
Esports.
EA Sports.
No, E, like E with a dash and sports.
But you have to choose, Jonathan, like which e-sport do you want? Do you want
Gaming.
no, I know what is e-sport, Jonathan. I'm asking you to pick one of your favorite e-sports.
Gaming.
Which one? Like, do you like do you like Fortnite?
No, I'm not a Fortnite guy. I'd say Minecraft.
Okay, Minecraft, that's good enough. So that's it, good enough. So 5 sports. What it will include is API to get data. Your project will have these things, pieces: API to get data, initial data exploration, filling in missing data using API or averages, etc. Data. Right. Yeah, I have to find out basically for all these. I have to find out. I know chess has a lot of data sets available. Cricket has some data set available. I know basketball has. I even know tennis has. I have no clue if Minecraft has data available. I don't even know what Minecraft data I can get. And then you would start doing like some identify correlations, strength of relationship, explore interesting questions, or answer some questions on the data set, visualize relationship between data, and so on. So this will be like multiple part project. It won't be like a one part project. So from next week, we can start, like by next class, I'll try to at least give you what kind of things. Let me think about it. So how many medals a specific country won each year? So that's the second question. Any other third homework question ideas? Right. Yeah. So initial data exploration is like statistics on data, right? Yeah. That's what I mean, data exploration. Okay. So how many medals a specific country won each year? Any other questions that you guys can think of? Okay, fine. We'll think of some questions. Maybe we'll give some questions on plots this time, mostly only on plots. And based on plots, answering some questions. Okay, cool. Thanks for staying 19 minutes over. If you don't have any other questions, we can see you till next week. Okay, Balaji, are you there?
Yeah, there. Hey, I'm there.
Hi. Yeah, I think a lot of people didn't submit homework still, right? Like based on what their homework answers were. Right. So wait a little bit. This one question on reading itself. So this time one question on reading the 8 plots. And then a plot of how many medals a specific country won each year. So this one you can make it interesting. Like you can say, draw 4 subplots of country versus gold, slash silver, slash bronze, slash total medals. So I think it actually is something like this. We can say plot dot subplots of n rows equal to 1 and calls equal to 4. And oh, did we stop recording?
Yeah, I think only 3 of us are there.
Yes, I'm just stopping recording. Okay.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramastercode.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!